This is unfortunately not a statistically significant difference because of all that noise that I was talking about and all the dilution with the people in the control group that I can't throw anybody out of the experiment, including the people who saw no ads. I have to compare the whole treatment group to the whole control group. So it's not statistically significant. I'm going to use a slightly fancier statistical estimator in order to show statistical significance, but this is about the difference that we think is there. And the problem is just that the standard errors are so high that we can't say it's significant, at least not at the 5% level. Now, here's a really important slide. Suppose that I use the ComScore methodology that was written up in Harvard Business Review. I want to pretend I don't have any experiments. So I'm going to throw out the control group, which was the thing that I did. I deliberately didn't show ads to a group of people. Let's just take the set of people who showed up to Yahoo, or didn't, see which ones saw the ads and which ones didn't, and compare what's the difference between those two in terms of their sales. Normally, people would use that to estimate the effects of advertising. What do we get? Well, the people who were exposed bought $1.81. The people who weren't exposed bought $2.04. There's a highly statistically significant difference of minus 23 cents for the effect of advertising. That is, you know, we're decreasing sales by more than 10% if we use this measure. That's not really what's going on. This is not a causal effect. This is, I'm grabbing two different populations who behave differently on Yahoo. These guys browse more, these guys browse less. It turns out the guys who browse more buy a little bit less at this store. And what we want to know is for the same group of people, how much more would they buy if we showed them ads? I'll try to convince you of that last assertion by showing you the data before there was any advertising delivered. And there we see $1.81 for those exposed, $2.15 for those not exposed. So in fact, the difference is bigger when they're not being shown ads. This is just different types of people. It has nothing to do with the advertising. We've selected two different groups, and then we're making a huge mistake by comparing them and assuming the only difference is whether they were delivered the ads or not. So ad exposures appear to have prevented a normal decline in sales during this time period, and my estimate is that sales have increased relative to everybody else. So the guys who were exposed had no change in their sales, $1.81 to $1.81. The guys who we deliberately didn't show any ads have a 10-cent decrease in sales. And the guys who were non-deliberately not exposed, like the people who just didn't show up and were also not exposed, look just like the control group in terms of time series difference. So I'm sort of taking people's intrinsic type and then seeing what's their change over time relative to the baseline. And I'm taking a difference in differences, and that tells me that I have a 10-cent difference due to the advertising. And that is statistically significant. It's got a standard error of 4 cents. The estimated sales impact for the retailer is 80,000 fake dollars, plus or minus 70,000. So it is a wide confidence interval. But compare that with the cost of the ads, which was only 20,000 fake dollars. And so we have incremental revenues that are 4 times the cost of the ads. Because this retailer is thought to have markups of about 50%, they're actually doubling their money on this particular ad campaign. Offline and online, what I can show you is that 93% of the effect happens offline, only 7% happens online. We don't capture the effects only by restricting to clicks, because while the clickers have a much bigger difference relative to the control group, the people who view also have a big difference. And when we multiply 14 cents by 93%, we get a bigger number than we multiply a 50-cent effect times only 7% of the population. And so actually 78% of the effect occurs with the people who viewed but didn't click. So conclusion, online display advertising increases both online and offline sales, 5% increase in revenue. Total revenue effect is about 4 times the cost of the ads. Perhaps more if the effects are persistent over time, or another thing I'm worried about, if the matching of records is imperfect, that means I'm accidentally putting some people from the treatment group into the control group. I think they're in the control group. So I'm showing ads to some people in the control group. That's going to bring treatment and control closer to each other than they really should be if I measure everything correctly. So I could be underestimating. 93% of this increase in sales occurs offline. 78% of the increase in sales comes from viewers and only 22% from clickers. And I'll let John talk to us about health records.